And that works, hopefully. Alright, so what is a identity? It's basically a mathematical statement that is true for all values of the variable. So for example, x plus y squared is x squared plus 2xy plus y squared. That's an identity because all of the values of x's and y's can be true. But why does 3x equal 12? Why is that not an identity? Yeah, so like e.g. if x equals 7, then that's not true, or 8, or anything that's not 4. Alright, so we'll start by putting a point on the unit circle, just like that. And we'll draw it up. So we know that the vertical component is sine x. Oh, well, x being the angle, just like that. And the horizontal component, we know it's cos x. Yep. So this is from methods? Yeah. Nice. So this point here is cos x comma sine x. So to find the magnitude, we need to square this, square that, and then use basically Pythagoras. But this is a unit circle, so we know the magnitude is 1. So we know that if we square cosine x plus sine x squared, we'll get 1. That's true for all cases. We can move the sign around, and we can get cosine squared x equals 1 take sine squared x, or we can get sine squared x to equal 1 take cos squared x. Your tan identity, if you remember TOA from Dr. TOA, tan x in this case, opposite over adjacent. Sin x over cos x. Now, do you guys remember the complementary identity? So, for example, sin x is the same as cos pi on 2 take x. And then for cosine, it's the opposite about sine. So you shift the phase out by pi on 2. Mr. Thompson showed you guys that? Is that last term or is that this term? Oh, okay, so it's all fresh. Oh, nice, so it's almost like the same thing. Functional identities. Sine, I guess this is revision then, which is good. Sine of negative x, sorry. Sine of negative x is the same as negative sine x. You can get sine negative pi on 4 equals negative sine pi on 4, just like that, nice and easy. cosine. So for example, if you have x, that's there, x goes down there, so that's why it's negative. Sorry. If you have x going that way, then you get this point here. If you have negative x going this way, you can get the same point, just flip. That's why you can bring out the negative. But for the cosine, if you have cosine of negative x, it'll be the exact same as cosine x. This is because the function is even and the graph is symmetrical. So x, say x was there, you would get this. If that was negative x, you get the exact same number. And that's why if you have a negative of the angle, it doesn't matter, because these two go to the same y value here. And of course tan is an odd function, so it's the same as sine. Tan negative x equals negative tan x. That one there, and then that one there. This is an odd function as well. Sine's an odd function. Even. Basically, an even function is symmetrical. About the y. And an odd function has 180 degrees rotational symmetry. About the origin. So you take this curve there, rotate it that way, you'll get that. So we're going to use this now and do proofs, which is pretty cool. Pretty cool indeed. So I'll do example 1 and then we'll try 2 and 3 by itself. Alright, so normally when you do proofs, you want to start with the complicating side. Or the side that's got more terms, normally. So it's normally easier to simplify something than to expand it and pull things out of nowhere. So in this case you can actually do both because they both seem like they're kind of the same. Let's just try to take the left hand side. So I'm going to take left hand side. Alright, so from SOHCAHTOA, tan x is sin x over cos x. So I'm going to change tan x to sin x over cos x. Let's do that. Alright. So that becomes sin x over cos x. Take sin x, cosine x. Alright, so now we got a fraction. I don't really like fractions, so I'm going to put the whole thing over the same denominator, which means in red or in a different color, multiply this guy by cos x over cos x. You following? So sin x take sin x cosine squared x over cosine x. Cool. Sorta getting to that guy. Sort of. So we have let's see. well, I want to get a sine squared x, but I have a cos x. Let's turn around, let's see. Well, I know that sine squared x is the same as 1 take cos squared x. So over here, well, I can get 1 take cos squared x if I factorize out sine x from my numerator. See that? So now this guy here can be sine squared x, squared x, and sine x over cos x is tan x. Cool. Just for a challenge, Macklin, do you want to try and take the right hand side? Yeah. See how you go? Basically working backwards to that one. Pretty good. Alright, so example 2, which one do you reckon we should start with? Probably left hand side, yeah. Let's take the left hand side. I think it's got 2 terms, so left hand side. That one's a little bit tricky, but I would probably break this up. So I would change that to sine x over cos x times cos x. Take sine squared x times sine x. Alright, so I can cancel that out. So this side here is sine x minus this guy is 1 take cos x squared times sine x. I can expand my brackets out. So I need to expand my negative bracket. And then this cancels out. and I'm left with sine x cosine squared x. Oh, sorry, that's meant to be up here. Alright, so I reckon that last one's pretty obvious of which side we take. We take the big side. Do you want to have it go by yourself, Macklin? Is that how you did yours, you reckon?
No.
Or did you get stuck? Which part? The first bit?
Yeah, that's good.
I guess once you get this, then you can just kind of try different things. It's a little bit confusing to begin with, but once you sort of get a hang of it, it's not too bad.